Okay, so just with this initial look at the graph, tell me what's going on.
The red car is decreasing in velocity, and the blue car is increasing in velocity.
All right, so show me on the graph how you get that. How you come up with that idea.
Because at that point in time, they are going exactly the same velocity because they cross. But then the red one goes down.
So red one started higher,
and the blue goes
higher, and it was decreasing. And the blue one started lower and got higher.
Yeah.
All right.
Over time.
Everybody agree with that?
Si, senor.
Is it recording?
Okay.
Yeah.
I'm going to ask you some questions here then. We already answered this first one. What does the intersection of the two graphs mean?
That they're going the same velocity.
Okay. At 10 a.m., noon, and 2 p.m. So find those on the graph for me.
That's about 10.
10, 12, and
12
and 2. Which car is ahead?
Right now, the red one's
Yeah.
ahead.
At the beginning.
At 10 it's red, at noon they're even,
Equal.
and at 2 the blue one is.
Okay. Everybody agree with that?
Yes.
Okay.
Sid, are you at the elementary office, please?
Will the cars ever be side by side again, and if so, when?
No.
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 Well, didn't you just tell us that they weren't going to be? How did you just tell me what you said at 10, 12, and 2 again?
That one is above, below. They're equal now. It's above.
Okay, and what I'm asking is which along the highway, where are they along the highway at those 3 times? You might not have understood the way I asked the question.
Where are they?
Where along the highway, where are they at 10, 12, and 2? Let's re-ask that question.
4th, half, and 3/4.
That one's behind it. And that one's equal
Okay.
to it. And that one's past it.
Okay, so you're saying that for this next question, that at noon they're side by side again?
Yeah.
Everybody agree?
Yeah.
Okay. And all right. Next thing I want you to do is try to model the cars. So either you can use some objects, or you can walk, whatever you want.
Car, blue car.
So
I
I
want
want you to
blue
model
car.
the movement of the cars. All right, now let's see how you do modeling this problem. So I'll do time, and you guys be the cars. Ready? 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. Okay. Here is a movie that shows what the cars actually do.
Okay.
Let's see how close you can.
What?
And watch the
They
movie
end at the same time.
and think about
yeah.
about it.
So I pretty much got to go all the way till
He
like
starts slowing down, he starts speeding up.
we're not even at noon.
Yeah.
Okay. So let's think about the graph again.
Their speeds
Turn around and
are
look at the graph.
okay. Never mind.
Tell me why you misinterpreted it.
The speeds are equal at that time.
The
Okay,
speeds are equal,
but
we're not
what-
equal.
What happens from 8 until 12?
8 until 12,
The
I'm
red
speeding
car's
up.
speeding
I'm
until
going
noon.
faster, and she's going slower. And then we like switch speeds at noon, and
What I wanna
I
know
go
is
slower and she
why?
goes faster.
Okay, so from 8 until noon,
Is the
what's the
blue car
relationship
supposed
between
to
the
be
velocities
faster
of the
than
red
car?
and blue cars?
The red one's above the blue.
Yeah, the red car is always going faster, right? So it's always going to be.
Winning.
All right, now, one more challenge for you.
We need to
I want you to graph 2 more cars.
Okay.
One car that's always behind, but catches up to him at 4 o'clock. and another car that's always ahead, but they catch up to him at 4 o'clock. So 2 more graphs. Together, there will be 4 cars altogether. A white car that's always ahead of the other 3, and a black car that's always behind.
Okay, so
There's
I
a
think
red, a blue,
if we
a
do
black, and a white.
a black one going like horizontally. No, that's speed. Wait, turn up.
How do you
Wouldn't
stop
it
this?
just like be really
Doing that.
It'd be
Hold on.
fast and then slow.
Like
and
so,
then
like a
Not
very
smart like
slow.
has to be ahead the whole.
Hold on.
Yeah,
But
the
that
whole
one
time,
was
but
ahead the
only-
whole time until the end.
Use
The
the
red car,
forward
blue car.
mouse.
We just
Exactly. This one has to be ahead of
Dang in
both.
the mouth. I'm sorry.
no, it didn't. Don't
So,
put me
like
on the
this?
internet.
Oh, right.
Wait, what if it starts lower than the red car, but no, it has to be ahead? No.
This is what's gonna happen if the red car.
Like,
Can you have it start at a different point?
would it be like that?
Kind of.
What, the white car winning the whole time?
This
Yeah.
A red car.
Draw your line. Oh, that's a white. We need a white one.
We
Why
need that
white?
would work.
Why?
Never mind.
Why white car? Or
Okay. Give
no,
me,
not the
Oh.
And why are you putting it there?
because if it starts and then gradually gets lower, it'll be ahead of the red car.
Okay, and the red car is, which car is ahead the whole way now? Red. So if you draw its graph above it like that, the white car will always be ahead.
Yeah.
But will it catch up to the others at the
So
same
it
time?
has to go like this.
So will it catch up to the others at the same time?
No.
Because it always, okay, let's see what you're doing. Okay, so is it going through that same point in the middle at noon?
Yeah.
Okay, could you even exaggerate a little more? Okay, so let's try that. Go ahead and,
But I wouldn't do it at the end.
Yeah,
That would-
yes, it would.
Okay, can I have the marker,
No,
please?
Devin.
What color?
Just get a
use that, you can just get the black one or the red one, it doesn't matter.
I can't.
Somebody help her hold the ruler there.
Yeah, no.
Devin, you must.
I didn't mess it up.
Why don't you exaggerate a little more?
And then the other one.
It's
Needs
gotta
to
speed
do-
up before the middle.
What?
The black one's gotta speed up before the middle if it wants to catch up to the other one.
So like this.
Yeah.
So basically the opposite of the other one.
Yeah.
Okay.
All right, you got faith in what you got there?
Yes.
Okay, I would agree with you. Now, why do you think you made the mistake?
Of what?
I
Because
think
we were
we-
thinking it was the cars, not the velocity.
We thought
Okay.
we thought that was the car's path, not the speed of it.
Okay,
That's what I just said.
okay, so
Whatever.
it's a very classic
Makes
graph
sense.
interpretation.
Classic myth.
We've done this.
You see where the graphs intersect, and you think that's where the cars intersect.
Yeah.
So very classic problem. All right, good job.